First, let's talk about some important vocabulary that you will need to know and understand for today's lesson. Partial products. This is a multiplication algorithm in which partial products are computed by multiplying the value of each digit in one factor by the value of each digit in the other factor. The final product is the sum of the partial products. We are going to look at this in more depth so it makes more sense on the next slide. Ballpark estimate. This is a rough estimate which is in the ballpark of the exact answer. A ballpark estimate can serve as a check of the reasonableness of an answer obtained through some other procedure, or it can be made when the exact value is unnecessary or is impossible to obtain. First, let's talk about using partial products with whole numbers. Before we start, I am going to mark each of our place values with their names. Above the 2, I'm going to write hundreds. Above the 3, I'm going to write tens. And above the 6, I'm going to write ones. This is just to help me keep track of what it is I'm multiplying. One important tip is to think of 236 as 200 plus 30 plus 6, which is the expanded notation form of that number. We're going to multiply each one of those parts by 4, which will have us using just basic math facts and is a little bit simpler than trying to multiply through and carry numbers. So first, I'm going to think about 200 times 4, and that equals 800. Next, I'm going to think about 30 times 4, and 30 times 4 is 120. And finally, I'm going to think about 6 times 4. 6 times 4 is equal to 24. The final step in this process is simply to add these numbers together. I have 0 plus 0 plus 4 in my ones column, which equals 4. I have 0 plus 2 plus 2 in my tens column, which also equals 4. And I have 8 plus 1 in my hundreds column, which equals 9, leaving me with an answer of 944. Let's look at one more example of the partial products method. As you can see, I have gone ahead and labeled my columns just like I did in the last problem. You are not required to do this, but it may prove helpful later on in the problem. First, in my mind, I am going to split apart these two numbers into their expanded notation. 26 becomes 20 plus 6, and 43 becomes 40 plus 3. Then I am going to go through and multiply all of these numbers together. First, I am going to work with 40 times 20, which is equal to 800. Next, I'm going to multiply 40 times 6, which is equal to 240. Next, I am going to multiply 3 times 20, which is equal to 60. And finally, I'm going to multiply 3 times 6, which is equal to 18. Then I just have to come back through and add all of my numbers up to come up with my final answer. In this case, 0 plus 0 plus 0 plus 8 is equal to 8. 0 plus 4 plus 6 plus 1 is equal to 11. So I will write the ones place, carry the tens place up to the hundreds column. Finally, 8 plus 2 plus 1 is also equal to 11, which leaves me with a final answer of 1,118. Next, let's review multiplication of decimals. There are 3 main steps that we must follow when multiplying decimals. First, we need to make a magnitude estimate of the product. Second, we need to multiply the numbers as if they were whole numbers. Third and finally, use the magnitude estimate as a guide to inserting the decimal point at the correct location in the answer. Now let's look at an example that will help us understand this process. I am going to use the numbers 1.3 times 5. The first thing I need to do is make a magnitude estimate of the product. When I round these numbers, I'm going to only round 1.3 because it's the only one that's not currently a whole number. 1.3 is going to round down to 1. And I'm going to come up with a product of 1 times 5, which equals 5. So I know my final product is going to have to be in the ones place. Next, I am going to multiply the numbers as if they were whole numbers. This means that I'm simply going to multiply 13 times 5 instead of 1.3 times 5. I'll deal with the decimal point at the end. 13 times 5 is the same thing as 10 times 5 from the 13, which equals 50, and 3 times 5, which equals 15. And when I add those two together, I get an answer of 65. Finally, I'm going to use my magnitude estimate as a guide to inserting the decimal point at the correct location in the answer. Since in my magnitude estimate I found out that 1 times 5 is 5, I know that my final answer has to be in the ones place, which means that my decimal point needs to go right between the 6 and the 5, making my final answer 6.5. 1.3 times 5 equals 6.5. Now let's look at that process one more time just to make sure we all understand. Let's multiply the numbers 3.4 times 4.6. First thing we need to do is make a magnitude estimate, which means that I'm going to round 3.4 down to 3 and 4.6 up to 5. Multiplying those two numbers together, I find 15 is my estimate. So I know that my final answer is going to have to be in the tens place in order to be correct. Next, I'm going to multiply 3.4 and 4.6 as if they were whole numbers, totally ignoring the decimals. 34 times 46 will look like this. I am going to use the partial products method to get through this answer. So I'm going to start out with 30 times 40, which is going to be equal to 1,200. Then I'm going to multiply 4 times 40, which is going to be equal to 160. Next, I am going to multiply 30 times 6, which is going to be equal to 180. And finally, I am going to multiply 4 times 6, which is going to be equal to 24. Then I'm going to go through and add all of these numbers together. So I've got 3 zeros and a 4, which is 4. I've got 0, 6, 8, and 2, which is 16. I'm going to carry the 1. And I have 2 and 3 ones, which is the same thing as 5. And since 1 isn't being added to anything, it's going to simply stay 1. My final answer for this is going to be 1,564. If you look back at my process, you can see where I broke apart my numbers into expanded notation to do all of my multiplication. 30 comes from the 3 in 34, and 40 comes from the 4 in 46. 6 comes from the 6 in 46, and this 4 comes from the 4 in 34. And then I simply made sure that I multiplied all of those numbers with each other to find my final answer. Finally, since my magnitude estimate was in the tens, my final answer has to also be in the tens. So instead of 1,564, I'm really going to come up with 15 and 64 hundredths as my final answer. I can check to make sure I've put the correct number of digits behind the decimal. Behind means to the right side of the decimal, by counting the number of digits behind a decimal up top. There's 1, 2 behind a decimal here, so that means that there should be 1, 2 behind a decimal here. And there are, so my answer is correct. Here is your practice problem of the day. You may choose to do either one of these problems. If you would like, you may also do both. Either multiply 79 times 46 or 5 and 4 tenths times 6 and 8 tenths. Good luck!